And still in Unit 3 here, we'll take a moment to review energy bar charts. The two main energy accounts that we worked with during Unit 3 were the thermal energy account and the phase energy account. When we talk about the thermal account, we're talking about the motion of particles, and when we're talking about the phase energy account, we are concerned with the arrangement of particles. Okay, whether they are strong attractions and orderly arrangement, or whether they're free flowing, or whether there are large distances in between in terms of gases there. So with thermal energy, we went with rule of thumb for how many bars to assign as we do these problems, but we also gave you some leeway and allowed you to make some decisions. So what I'll do here is I'll put the rules of thumb, and that's that if we have 1 bar, the situation would be that is cold, a cold environment. 2 bars typically represents room temperature, so anywhere between, like, let's say 20 and 25 degrees. And then anything above 2, you start to get into a warmer environment, so you have some decisions that you'll need to make. But when we get to the maximum number of bars, this would be hot. Phase energy, 1, there is an orderly arrangement, stronger attractions between particles. Attractions are not overcome, so there's vibrational movement. That would be our solid. 2 bars would be a liquid, and 4 bars would be in the gaseous phase. So I'll leave that up there. We'll go ahead and we'll fill in our energy bar charts. Just so we're all aware, I'll go ahead and just put a line through our chemical energy since we did not work with that in first semester. But what we have to do here is we have some decisions that we need to make when doing these problems, and I'm going to go with kind of a standard, and if you disagree slightly, that's probably okay, as long as your final answer ends up matching the final answer here. So some of the water you spilled on your shirt evaporates. So the first thing we need to identify is water. The water is evaporating, so the water exists in the liquid state. So if that is true, liquid state is 2 bars, so we give ourselves 2 bars here and fill it in. And because that water is evaporating, it's going to a gas, so we come over to our phase energy and our final conditions, and we go to 4 bars. So it's always good practice to go ahead and as you're doing these, to write down the number of bars at the bottom, 2 and 4. That way at the end, that will help us to identify the amount of energy coming into the system or leaving the system. Okay, and we go ahead and move on to the thermal energy. It doesn't mention anything about the actual temperature, so what we can assume here is that it's room temperature. Okay, if you are going to go with something else in your head and you think that makes sense, it could work out, but at this point it's not really mentioned anything, so why should we assume it's anything other than room temp? As we all know, if we put a glass of water on a counter at room temperature, over time that water will evaporate. So again, it gives us no indication of a temperature change over time. So we could go ahead and keep 2 bars. Now I know some students, when we did this before, looked at this and thought, well, maybe body heat is increasing the temperature, so they were to give it 3 bars. And I'm okay with that if that's what you choose to go with. But personally, there's no mention of it, so I stick with it's just room temperature. So what we have in the initial conditions are 4 bars, final condition 6 bars. The difference between 4 and 6 is we had to add 2. So by adding 2, we have to show 2 bars of energy coming into our system. We need to label it Q. And because energy is being absorbed, this is an endothermic reaction. Okay, let's move on to number 2. I'll change colors and just differentiate between the two, make it easier to follow. Water vapor in the room. So water vapor, 4 bars, it is a gas. Okay, that water vapor condenses. When something condenses, it goes from the gaseous state to the liquid state. So it drops to 2 bars. Okay, we're not going to worry about our chemical energy account, so we can either just leave it empty or exit out. But the water vapor in the room, if it's in the room, it's at room temperature. Or is it? Was it heated up? Are we given any real information about the vapor? Now, some students may go ahead and say it's at room temperature because it says in the room. Some students may say, well, it was a vapor because it was heated up. We don't really know, but what we do know is that it's falling on a cold surface. So to bring it down to 1 bar and say cold, that's good. I'm going to go ahead and go with 2 bars because it says the vapor in the room. Okay, what we have here, 2 bars and 4 bars on the left for initial conditions, 1 bar and 2 bars on the right for final conditions. 6 to 3, how do we get there? We have to take away 3. So here, 3 bars going out. Q, energy is leaving the system. And again, our system is the water vapor. So anytime energy is exiting the system and going from system to surroundings, it's an exothermic reaction. So hopefully this helps and acts as a good review. But to highlight the main parts, we need to be able to remember the number of bars that we're supposed to use for our thermal and phase energy accounts. We should be consistent with the number of bars. We should label the system. We should label the amount of energy for each account on both sides. And when we determine whether energy is being absorbed or released from system to surroundings and vice versa, we need to label that Q. And then to be able to label a reaction as endo or exothermic is very important. Endo meaning energy is coming in. Exothermic meaning energy is exiting. So good luck with them.